Hi, welcome to the flipped instructional session for Math 08A for Unit 502, Systems of Linear Equations. Our objectives in the lesson today are to determine whether an ordered pair is a solution to a system of linear equations and to explain why an ordered pair is or is not a solution to a system of linear equations. So a system of linear equations is part of our vocab, and it's just two or more equations that we're solving at the same time. And so an example of that is this. This is a system of equations. And a solution to this system of equations is actually an ordered pair. So we're going to have a value for x and a value for y, and we write it as an ordered pair. So something I just want to briefly talk about in Unit 2, when we were solving equations, we found that you could have one solution, no solution, or infinite solutions. And we have that same case here. And so what we're going to find, just visually, if we have one solution, our system of equations, when they're graphed, intersect one place. There's one solution, and that's our ordered pair. They intersect one time. This is about 90% of the problems we do. There's no solution. The lines are parallel, and they never intersect. So we're not going to find an x and a y that work. So we'll get false statements here, just like we did in Unit 2. If we have infinite solutions, when we graph, we find that when we graph the two lines, they're actually the exact same line. They overlap. It's terrible overlapping line. It's very curvy. So they always intersect. And we're going to find this is when we get those true statements. So there are three options for a solution, but generally speaking, one solution and it's an ordered pair. So we talked about in Unit 3, when we first looked at equations that had x's and y's, we talked about how ordered pairs is just one of the ordered pairs that lay on this line. There's an infinite number of ordered pairs, but we figured we could plug these in. We could make a table. We could actually graph the line, figure these out, but we can just plug this in. So we're going to do 3 times x minus 2 times y and see if it equals negative 22. So if we plug in 4 and 5, 12 minus 10, well, that's not negative 22. So I know that's not going to work. So let's just erase that. So now we'll plug in negative 4, 5. And I get negative 12 minus 10. Waha, there's negative 22. And this is just asking for one ordered pair. So that is an ordered pair that works. So what we're going to find now, when we have a system, these two together, these two together, these two together, the ordered pair has to work for both sets. So let's look at this first one. 3x minus y, I just put it in parentheses, equals 7. And then 2x plus 3y has to equal 1. So if we try this 1, 1 first, we have 3 minus 1. Well, that's definitely not 7. So 1, 1 is not going to be a solution. I don't need to go any further. Let's check 2, negative 1. 2, negative 1, 2, negative 1. So this would be 6 minus minus, so 6 plus 1 equals 7. Yep, so let's check this. 4 minus 3, yep, 1 equals 1. So 2, negative 1 works for system 1. because 2, -1 was true for both equations. So let's look at number 2. -3x minus y equals -2, and then x minus y equals 6. So we'll try our 1, 1 first. -3 minus 1 is going to be -4. So nope, that's not going to work. So let's plug in 2, -4. So -6 plus 4 is -2. 2, change. So 2 plus 4 is 6. So 2, -4 is a solution for system 2. So process of elimination, we could work it out, but this is going to be 3. So is 2, 3 a solution? So we would just plug this in and figure that out if it made sense for both. So we are not actually going to work through that. What I do actually want to show you is kind of an introduction to graphing. So let's take these and let's work on graphing these because that actually comes up next. And it'll be a good review. So let's do that. So we're going to graph, solve by graphing. So we have x minus y equals -1 and 3, whoops, should have just written it, 3x plus y equals 9. All right, so let's review some graphing. We could do a couple things. We could make a table, which I think would be a little rough. We could do intercepts. So maybe we'll do intercepts today. Or we could rearrange this, but I think intercepts would be a good idea. So when we find intercepts, we plug in 0. So in this case, we get -y equals -1, which is y equals 1. So when we plugged in 0 for x, we got 1 for y. So that's one intercept for this x minus y equals -1. The second intercept, instead of plugging in 0 for x, we plug in 0 for y. So we get x minus 0 equals -1. So x equals -1. So -1, 0. So we have 2 points, 0, 1, and -1, 0. So to find intercepts, you plug in 0 for x, plug in 0 for y. So let's do that for the next problem. There's just a little review of graphing here. (3x plus y equals 9). So to find one intercept, we plug in 0 for x. So we find y equals 9. So 0 we plugged in for x, so 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, way up here. And then we plug in 0 for y. So divide both sides by 3. X equals 3, so 3, 0. Well, this is going to be real wonky. Woo! That is really crazy. I don't know why I did that. Let me get that eraser. At least get rid of that crazy line. So we see these are our 2 lines. I have one here. And this is just a guesstimate since I one here. So the solution is this ordered pair right here. And so when you did it on graph paper, you will actually be able to read this, but this is how we do it. We graph and then where it intersects is the solution. And we did that by using intercepts. So look at your Class Connects schedule for the flipped follow-up session or a help lab to get more help on systems of equations.